Let us discuss lesson number 3, Introduction to Data Analysis. So today we're going to discuss the following topics: classification of sampling techniques, research designs, and hypothesis testing. Classification of sampling techniques. So we have two, the non-probability sampling techniques and the probability sampling techniques. So these are ways on how to get your sample data from a given population. What is a non-probability sampling? It is characterized by the fact that some units in the population do not have a chance of selection in the sample. Other individual units in the population have an unknown probability of being selected. There is also an inability to measure sampling error. So meaning, when you get sample data, not all people have equal chance of being selected. Meaning, kung sino lang yung available, kung ano lang yung kailangan mo, that will be your sample data. So, dito sa non-probability sampling, may bias approach sa pagkuha ng sample. So, it has four types, the non-probability sampling techniques: convenience sampling, judgmental sampling, quota sampling, and snowball sampling. What is convenience sampling? Respondents are selected because they happen to be in the right place at the right time. Example, using students and members of social organization, also people in the street interviews. Let me say convenience sampling. Let's say, for example, I will conduct a survey to students about online class problems. So, ang kukunin kong sample, kung sino lang yung online, kung sino lang yung laging may data, sa kanila ko ipapasurvey yung questionnaire ko. So, I will message the student kung sino lang yung mga online, laging online. So, sila yung sample data. O, parang magpapasurvey ka, mga customers sa Jollibee. O, syempre, hindi mo na mapipili yun. Kung sino yung pumasok sa Jollibee na naabutan mo ng mga oras na yun, at the right time, right place, so they are your sample data. Letter B, judgmental sampling. It's a form of convenience sampling in which the population elements are selected based on the judgment of the researcher. Example, purchase engineers being selected in the industrial market research. Also, expert witnesses used in court. Judgmental sampling, kunwari I need sample respondents for my survey. So how am I going to select from my students? So, kung sino lang yung matalino sa klase, kung sino yung mabait, responsable, sa kanila ko ipapasurvey. Kasi I know that they will answer all my survey questions. So, hindi nila ima-murder yung mga questions ko. Lahat sasagutan nila kasi they are responsible students. So, nag-judge ka. Pinili mo yung magagaling, yung mga dean's lister, yung matatalino sa klase, mga responsable. So, yun ang paraan mo ng pagkuha ng sample. Next, quota sampling may be viewed as two state-restricted judgmental sampling. Quota controls this, then sample selected based on convenience or judgment. So ito naman yung may limit yung pagpili mo ng sample respondents. Let's say, for example, I need 3 students only in my class that will answer my survey question about online class problems. So, ang gagawin ko, para mapili yon kung sino yung online, tapos yung isa kung sino responsable, tapos yung isa kung sino matalino. So, gumamit ako ng convenience sa judgmental sampling. Pero nag-limit ako ng sample respondents, just 3 students. Then, snowball sampling, an initial group of respondents is selected, usually at random. After being interviewed, these respondents are asked to identify others who belong to the target population of interest. Subsequent respondents are selected based on these referrals. So, magpapa-online survey ulit ako. I need sample respondents. So, ang respondents ko, pwedeng working students. Okay? So, kailangan ko ng mga working students para mag-answer ng survey ko. Eh, syempre, sa klase ko, 2 lang na may working students. So, paano ako magkakaroon ng 10 kung kailangan ko 10 or marami? So mag-aasa ko dun sa mga working students ko na mag-refer sila ng iba pang working students na pwede magsagot ng survey ko. So, referral. So, from their referral, makukompleto ko yung sample data. So, we're done with this non-probability sampling techniques. Let's now proceed with probability sampling techniques. Dito naman, every population element has a known non-zero probability of being selected in the sample. This makes it possible to estimate the margin of sampling error. Therefore, all statistical techniques such as confidence interval and hypothesis testing can be applied. So, this probability sampling is more comprehensive. Wherein, gamit ka na dito na statistical treatment, yung mga hypothesis testing, confidence interval, and then all people in the population have equal chance of being selected as your sample. So dito wala kang bias ng pagkuha or pagpili ng sample data or sample respondents. Lahat may chance ang mapili. So meron siyang 5 techniques. Una, simple random sampling. Each element in the population has a known and equal probability of selection. Ito yung tinatawag na draw lots or lottery method, so bunutan. So example, sa BS-RS third year, kailangan ko ng respondents o samples respondents. So ang gagawin ko, lahat kayo, papasulat kayo yung pangalan sa papel, tapos bunutan. So lahat kayo may equal chance mapili. Then systematic sampling. The sample is chosen by selecting a random starting point and then pick every kth element in succession from the sampling frame. Ang tatandaan nyo ditong keywords, every kth element. So dito naman, sa pagkuha ng sample, example na sa classroom kayo, kailangan ko lang ng mga ilang estudyante for my sample respondents or data. So lahat kayo, mag-a-assign ako ng number. Bawat isa may number. Tapos sasabihin ko, kung wari every third student will be my sample data. So pag every third, multiple of 3. Ibig sabihin every third, every sixth, 9th, 12th, 15, 18, and so on and so forth. So sila yung sample data ko. Next. Stratified sampling. Probabilistic equivalent of quota non-random sampling whereby things we might use as a culture control such as gender, age group, nationality. Ito yung gumagamit ka ng strata. Distinct group. Kumbaga, you're getting sample by culture control like gender. Male or female. So, anong pipiliin kong sample data? So, lahat lang ng male. Tapos, i-compress ko siya, i-cluster ko siya. Age group naman. So, lahat ng male na edad, 18 years old. Tapos, nationality, lahat lang ng Filipino na 18 years old na male. O kaya naman, pag sinabing stratified sampling, choosing sample from distinct group. Kumbaga, you can recognize the group. Example, kukuha ko ng sample data from group of doctors, group of teachers, group of students, group of engineers. So, wala siyang saktong bilang. Basta huhugot ako ng mga tao from those distinct groups. Then, cluster sampling. We would consider dividing our total population, for example, students into these mutually exclusive and collectively exhaustive clusters. Example, the different universities, we could take a random sample of all these clusters. So, dapat, yung pagkuha mo ng sample, you will consider mutually exclusive and collectively exhaustive clusters. Example, in DICE. Pag sinabing mutually exclusive, if I roll a dice on the floor, if I roll a dice on the floor, and hindi naman pwedeng mangyari na pag nag-roll ka ng dice, sabay na lalabas yung 6 saka 3. So it will not happen at the same time. So 2 events that will not occur at the same time. Yun yung mutually exclusive. Pag sinabi naman collectively exhaustive clusters, ibig sabihin, when you roll a dice, so ang chance na makuha mo ay 1 to 6. So lahat sila may chance mapili. 1, 2, 3, 4, 5, 6. So parang ganito. I want to have participants para sa intram, sa CSIT. So meron tayong 5 games: volleyball, basketball, badminton, chess, and table tennis. So pag sinabi kong mutually exclusive, pag yung isang participant, isang student, sumali na sa volleyball, hindi na siya pwedeng sumali sa basketball. So isang game lang pwede. Kasi nga, 2 events will not happen at the same time. Pag naman sinabing collectively exhaustive, it means all the 5 games dapat may participants. So, kung meron kang participants sa basketball, dapat sa volleyball, chess, table tennis, dapat badminton meron din. So, hindi dapat may ma-skip ka doon. So, dapat lahat may participants. Multi-stage sampling. Ito naman yung you will perform at 2 or more successive stages. Kumbaga, pwede mong pagsama-samahin yung mga probability sampling techniques. So, umpisa, pwede kang mag-draw lots, yung random sampling. Then afterwards, mag-every ka, yung systematic. So, every 8 student, 8, 16, 24, 32, ganon. O, pwede mo pang i-apply yung isa pang sampling, stratified. So, by distinct group. So, pinagsasama-sama mo sila. Kasi yung iyong population sobrang malaki. So, papaliitin mo by applying different probability sampling. So, we're done with this classification of sampling techniques. Let us proceed with the research design. So, we have 11 research designs, and let us discuss one by one. So, number 1, qualitative research design determines relationships between collected data and observation based on mathematical calculation. So it answers the questions why and what. So we have 2 main type of research, qualitative and quantitative. Tapos yung quantitative dito, the rest of the research designs under siya ng quantitative, like descriptive, correlation, experimental, comparative, lahat yan under ng quantitative. Let me see qualitative research design. Example, the title of my research is Perception of Closet Gaze in a University. So this is the title of my research. So in this case, pag qualitative, ang ginagamit mo interview method. And then, if they have similar answers, you will use coding. Example, if you will ask the closet gaze, why they prefer not to disclose themselves or to hide. So they will say they are shy, tapos they will say their parents will abandon them. So, kung may pare-parehas na sagot, i-code mo siya ng kumari, code A, like that. It answered the question what also, like, what are their preferred cologne, wardrobe, syempre closet gay, tatanungin mo kung anong paboritong amoy ng cologne or perfume, tapos anong paborito nilang suotin ng mga damit. Then, anong prefer nilang hairstyle. So, pag may magkakaparehas, i-coding mo. So, pag qualitative research, wala siyang hypothesis testing. Walang kang gagamitin statistical treatment. More on narrative form. Next, quantitative research design, from the word itself, quanti, so more on computation. So, ito na yung comprehensive. Gagamit ka ng statistical treatment. Okay, so ito yung meron na tayong hypothesis. Okay, next, descriptive research design, under siya ng quanti, as I told you, helps provide answers to the questions of who, what, when, where, and how associated with a particular research problem. It cannot conclusively ascertain answers to why. So, hindi niya masasagot yung why, but the rest of the questions, it can able to answer. Okay? Descriptive research, ang mga title pwedeng assessment of Ang ginagamit mong statistical treatment dito, syempre yung descriptive stat. At meron tayong descriptive measures na ginagamit. The one that I taught you last time. The measures of central tendency and dispersion. Measures of dispersion. Ang madalas ginagamit pag descriptive research, mean and standard deviation. To describe and summarize the characteristic of your data. Next one, number 4, correlational. From the word itself, relation. So ito, it used to determine the relationship between variables. Meron tayong common na ginagamit na correlation, yung Pearson R. Relationship between two variables. Example na pa title, the relationship between learning styles and math achievement. Ayan. So we have here two variables that we're getting the relationship, learning styles and math achievement. Then experimental. Sa pag-experimental research, medyo higher na ito. The test that we're going to use is statistical treatment. Madalas ginagamit t-test. Tapos, more on ang mga title niya, yung the comparison or the assessment also of the performance of students in math and science. So, kino-compare mo yung means nila. When you're comparing the means, t-test ang ginagamit. So, more likely, pag experimental, ito yung nagbibigay ka ng pre-test, post-test. At may mga treatment group, traditional group, control group, before and after, yung mga ganun ang ginagawa. Then, comparative study, from the word itself, comparison. Example ng title, a comparison of 3 Jollibee branches in Santa Maria, Bulacan, in terms of sales and customer satisfaction. Yan. Comparative study yan. Kasi you're comparing 3 Jollibee branches. Saan nga ba yon? Sa Santa Maria, yung mismong sa bayan, tapos dun sa Santa Clara, tapos sa Walter. Then cohort study, ito naman yung longitudinal. Parang the effect is being monitored over time. So hindi mo siya magagawa, yung research na to, in just isang upuan lang or nagpa-survey ka. Matagal ito. Pwedeng untitled, the dropout and retention rate of batch 2016. So, ibig sabihin, susundan mo sila. Mula first year, di ba, 2016, graduate sila. So, batch 2013 sila. 2013, first year sila. 13-14. Tapos, 14-15, second year. 15-16, third year. So, kulang pala. 2012. Obserbahan mo kung wari yung IS nung time na yon from first year college to fourth year college. Kung ilan na natira. Kung may nag-drop ba, tapos ilan yung nag-retain, na-retain. So, reason bakit sila nagda-drop, bakit hindi nakaka-graduate, konti na lang natitira pag fourth year. So, yun yung cohort study. Mixed method. Pag sinabing mixed method, ito yung quali-quanti. Kinumbine mo yung interview, qualitative research, saka quanti. Gumamit ka ng statistical treatment. Nag-compute ka rin. Then action research. Ito naman yung, syempre, example, online class problems. Ang title mo, action research about online class problems. So, in action research, mag-start ka muna sa planning, then act, then observe. Tignan mo kung nag-improve ba. Then, dito ka mag-reflect. Kumbaga magko-conclude. Recommendation, like that. Causal comparative naman, ito yung cause and effect. Relationship, comparative eh. You're comparing two variables. Pero may cause and effect siya. Relationship between independent and dependent variables after an action or event has already occurred. Then descriptive correlational, kinombine mo yung mga gumamit ka ng mean, median, mode, standard deviation sa mga correlational title ng research like the relationship between social media and study habits. O mga ganun. Then hypothesis testing. It is a decision-making process for evaluating claims about a population. So, always remember this decision-making process. So, you're making conclusion from sample data, and you may now conclude about the population. So, in this process, the researcher must define the population under study. Example, ICI students. State the particular hypothesis. So, hypothesis mo, all ICI students are good academically. Give the significant level. So, how true is my statement or claim about the ICI students being good academically? So, what is the error of stating that statement or claim? Then, select a sample from the population. Example, IS third year. Collect the data. I will conduct a test to your class. Then perform the required test. So after I conduct a test, syempre I will record, tabulate your scores. So pwede ko siyang gamitin ng correlation, ANOVA, t-test, kung ano man yung applicable na statistical treatment. Then reach into a conclusion. So magkakaroon ako ng findings of the study. Ano nakita kong result? Paano ko siya explain? And then we have two types of hypothesis, null and alternative. Age of 0 for null, age of 1 for alternative. And we have three possible sets of statistical hypothesis. Ito. So we have here, number 1, lagi sila magkasama, yung null sa alternative. Age of 0, null hypothesis, parameter is equal to specific value. And then alternative hypothesis, parameter is not equal to specific value. So bakit siya tinatawag na two-tailed? Kasi gumamit ka ng not equal. If you will notice, lahat ng null hypothesis dito, lahat gumamit ng equal. Ang null, lagi siyang equal. Kasi pag sinabing null hypothesis, i-define ko sa taas there is no significant relationship. There is no significant difference between the actual observation and the claim from a sample data and the claim about the population. So wala daw pinagkaiba yung narinig ko sa nasaksihan ko. Pag sinabing narinig, di ba, hypothesis, palagay, hinuha. Example, sabi nga daw, pag ICI students magagaling, paano ka ipoprove? So, kukuha ko ng sample data sa school nyo, magbibigay ako ng test, tapos nakita ko, magagaling nga, matataas yung nakuhang scores eh. So, walang pinagkaiba yung claim sa population ng ICI students saka dun sa actual observation by giving a test to a sample data. Example, yung section nyo, lahat kayo matataas yung nakuha sa test. Aside from no significant difference, ginagamit din dito yung no significant relationship. Ginagamit mo rin dito yung no significant effect. So, ganun sa null hypothesis. Lahat puro no. So, pag walang difference, ibig sabihin equal. Kaya kung makikita nyo yung 3 sets of possible statistical hypothesis, lahat equal yung null. Then, pag sinabi namang alternative, there is a significant difference, relationship, effect, impact, sa lahat ng there is, babaligtarin mo lang yung null. Di ba lahat ng null, there is no. Ito lahat there is. So may pinagkaiba yung narinig mo and yung na-witness mo. So ang narinig ko na hypothesis sa ICI students, magagaling. Siyempre, ipoprove ko yun. Pupunta ako sa ICI, magkakondak ako ng test sa isang grupo lang ng estudyante. Na lahat sila mabababay nakuha or failed sa test ko. So may pinagkaiba yung narinig ko sa na-witness ko na nagbigay ako ng actual test sa mga sample data ng ICI students. Okay? So pag sinabing null, lagi siyang walang matimbang. Kumbaga balance, equal, no significant difference. Pag alternative, may nakakalamang, may nakakababa. Basta laging may pinagkaiba. May relationship, may effect. So, these are the 3 possible sets. Ayan. Kaya siya tinawag na two-tailed test kasi gumamit ka ng not equal. Example, null. The average daily allowance of ICI students is 20 pesos. Is equal to 20. Then, ang alternative mo, the average allowance of ICI students is not equal to 20. Pag sinabing not equal to 20, either greater than or less than 20 yung baon nila sa isang araw. Number 2, left-tailed test. O baka siya tinawag na left-tailed kasi ang ginagamit na symbol sa alternative less than. Pero laging ang lahat ng null mo equal ang ginagamit. Number 3, right-tailed kasi ang alternative mo greater than. As usual, ang null laging equal. Okay? Example, number 1. Claim. The average monthly income of Filipino families who belong to low-income bracket is 9,000 pesos. So, ito yung claim natin. So, i-distinguish nyo kung ito ba ay null or alternative. Kung wari, hindi nyo nakikita yung sagot na ito. Wala. So, saan siya belong? Null or alternative? Our claim. Ang ginamit natin dito na verb ay is. Pag sinabing is, equals. Tama ba? So, automatically, pag equals, yung ginamit mo, null automatic yan. So, ibig sabihin, yung ating claim, kinapipaste lang natin sa null hypothesis. So, pag ang null mo equal, automatically, ang iyong alternative not equal. So, ganun mo siya i-contradict. Pag ang given mo null na equal, automatically ang pang-contradict doon not equal sa alternative. Next, example number 2. Sabi dito sa claim, the average number of hours that it takes a 10-year-old child to learn a certain task in a specific subject is less than 0.46 hours. So, ang average na oras na kayang isagawa ng 10 taong gulang ang isang task ay kaya niyan gawin less than 35 minutes. Kasi pag sinabing 0.56 hour, 35 minutes, magagawa niya yung task. Gumamit ka ng words na less than. So, automatically, pag less than, yung claim mo, saan mo ito ilalagay? So, lalagay mo lahat to sa alternative. Copy-paste mo lang. So, automatically, ano ang kanyang contradiction sa null? Alam niyo naman ang null, laging equals. So, kung dito is less than 0.56 hour sa alternative, sa null is equal to 0.56 hour. Okay? Then we have 2 types of inferential decision error. Type 1 error, and type 2 error. So type 1 error occurs if one rejects the null hypothesis when it's true. It is also called alpha error. And then type 2 error occurs if one does not reject the null when it's false. It's also called beta error. Ayan, beta symbol, then error. Okay? So pag sinabing type 1 error, reject true. Nireject mo yung true. So nagka-error ka. Parang nireject mo yung tama. Type 1 error yon. So type 2 error, inaccept mo naman yung mali. Alam mo ng mali, inaccept mo pa, anong error na commit mo? Type 2. Okay? So pwede mo siya ilagay sa table. Yung type 1 saka type 2 error. Example, this combination. Yan, lahat na naka-purple color. Nireject mo yung null, o nireject mo yung tao, kahit yung tao na yon, si null, loyal naman sa'yo. So, nireject mo yung loyal, nagkamali ka doon. Ano na commit mo? Type 1 error. Okay? So, what if, ang ginawa mo naman, hindi mo na-reject yung null. So, pag sinabing do not reject, accept. In-accept mo yung tao kasi alam mo yung tao loyal sa'yo. So, ano na-commit mo doon? Correct decision. Tama yung ginawa mo kasi reject, accept true. Pag sinabing do not reject, accept. So, in-accept mo yung true. O, tama yung ginawa mo. Correct decision. Okay, so next. What if ito namang combination na to? Itong tatlo. So, ang ginawa mo naman, nireject mo yung null kasi alam mo yung null false. Nireject mo yung mali. O, kung wari, meron kang kaklase na aya ka ng maling gawain, nireject mo yon. So, tama yung ginawa mo. Anong ginawa mo? Correct decision. Or what if, ang ginawa mo naman, in-accept mo yung null, do not reject, in-accept mo yung null, kahit yung null na yon, false. So, ano na commit mo? In-accept mo yung false, in-accept mo yung mali. Type 2 error. Okay? So, let us summarize this table. Accept, lagay ko muna, reject true. Kapag nireject mo yung true, anong na-commit mo? Correct decision. Sorry, type 1 error. Okay? Pag in-accept mo yung true, what did you commit? Correct decision. What if you accept false? In-accept mo, alam mo namang false. Type 2 error. How about reject false? Alam mong mali, ni-reject mo. Ano na-commit mo? Correct decision. Don't forget this 3. Very important, as in. Okay, so since we control for the probability of a type 1 error, alpha, what value should this be? Well, in general, we tested the 100% alpha percent significant level from 0 to 1. The default choice is alpha 0.05. Yan na madalas na ginagamit na error, 5% significant level. Then when alpha is equal to 0.05, there is 5% chance of rejecting a true null hypothesis. Makocommit mo yung anong error? Reject true. Type 1 error. Then level of significance. It is the maximum probability of committing type 1 error. Yung nireject mo yung true. So meron tayo dito nakalagay, we could view the significance level as the complement of confidence level. For example, okay, so 90% correct decision or confidence level is equal to 10% significant level or 10% error. Pag in-add mo kasi sila, 90 plus 10%, 100%. Pag 95% naman yung confidence level mo, correct decision, ilan na commit mong error? 5%. Ang tawag doon significant level. So 5 plus 95, 100%. Pag 99% naman yung correct decision mo, ilang percent yung nakommit mong error? 1%. So itong tatlo na to, 10%, 5%, 1%, ito yung madalas ginagamit na level of significance. Probability of committing type 1 error. Kung ilang percent yung makocommit mong type 1 error.